That's the crane.
This is the main
stay.
the main boom, right?
Right. And the moments would be acting right down here.
Yeah, this is where you
attach it to the ground.
Exactly.
Right here.
And then you have
your boom.
the lifting boom, which is over here.
Right.
And then you have a jib. You have a jib boom
with the concrete block on it.
Yeah. These blocks can be changed for weight.
They can be changed for weight, but once the job starts, they're stationary based on how much you're going to have to lift during the job.
Yeah, exactly.
So my question is, why don't they move the thing back and forth?
It moves up and down.
But up and down wouldn't change the moment.
If you bring this part of the crane,
the whole angle of the
crane? It all
crane?
goes up.
The whole angle of the crane like this?
Everything goes up. Like, this is the lifting arm right here, right? It goes up at the same time the jib goes up. So they create like a V.
Are you sure?
Yes. Yeah.
I don't think there's a hinge in it.
They move. They're articulated jib booms. That's what they do. They move.
These things confuse me.
They move.
The ones I've seen do not move.
The ones you see are old.
So how did they work it in the past?
I don't know. I'm new at this. They do move.
Okay.
Yeah.
I'm just highly confused.
Yeah. Because there are different articulated angles, and you can get. I can actually. Well, I couldn't show you because that would be.
Well, still the math of it's kind of weird because.
I don't talk to me about the math.
Well, that's the only thing I understand.
Yeah,
it's like when you have, say, this boom that goes like this, and say this is the center, this is the backstay, and this is the boom.
Yeah.
When it goes like this, that doesn't really alleviate much moment.
Yeah, I wouldn't imagine it would, but it does do that.
I could see maybe if the whole thing tilted like that or like that, that would change something.
I'm not sure how it stays.
I honestly don't think there's a hinge in it.
It moves. Trust me, it moves because.
That's the more stressful in each bar.
That's what always got me, because they put them in these triangular, like the booms are in triangles, right? And
yeah, to make it like a truss.
They're always going to have, there's always going to be one point where the triangle is at its weakest. You're never utilizing the full thing. That's why they should become circular, I think. I don't know, I'm not an engineer. I guess.
How does it work? Why doesn't it fall over?
Because it's got a counterbalance on it.
Yeah, but why doesn't it fall over when the counterbalance is in place and there's nothing on the boom?
Because there's a little bit of stiffness in the vertical component, but they've got a gauge on it that shows how much stress is taking place, and you know what they can lift. You can lift like heavyweight closer to the.
We understand that. But why doesn't it move back and forth so they can optimize how much they can lift?
They could, but
they don't.
Requires
why don't they?
Because it's cheaper to just use steel than to put a motor in.
No, there already is a motor in there. Why not just attach the same one?
You could do that, but
I don't see why they don't.
Well,
attaches the same one because as it moves out, you might as well have your counter.
Not a bad idea.
See, there you go.
But then you're going to rely upon mechanical devices to.
You already rely upon mechanical devices.
Okay.
Well, no, if you were to do like a...
See if you get someone to insure it.
Oh, why do you got to be like that? What? That's such a sissy way out of the conversation.
End of story.
Let's go.